Do not lower your goals to the levels of abilities. Instead, raise your abilities to the height of your goals by Swami Vivekananda. A very good and warm morning to all of you. Myself, Neha, Assistant Professor, Department of CSE in EPCET. I feel privileged to extend my warm welcome to all of you who are present here for the International Conference on Emerging Trends and Innovation in Science, Engineering and Education. I request all the dignitaries to kindly come over the dais and occupy their honorable seats. To begin this auspicious occasion, I would like to invite Dr. Sen Kamalavalli ma'am to sing an almighty song.
Mahaganapatim manasa smarami Mahaganapatim manasa स्मरामि वशिष्ठवामदेवादिवन्दित महागणपतिम् महादेवसुत महादेवसुत गुरुगुहनुत मानकोटि प्रकाशम् शान्तं महाकाव्यनाटकदिप्रियम् श्रीमहाकाव्यनाटकदिप्रियम् मूषिकवाहनमोगदप्रियम् महागणपतिम् मनसा स्मरामि महागणपतिम्.
Thank you, ma'am. Light fades away darkness. Light symbolizes knowledge and wisdom free will. To solemnize the special invitation, I request all the dignitaries for lamp lighting. I request our Vice Principal, Dr. Yogesh sir, to join me. I request our Mechanical HOD, Sir Prakash sir, please join, sir. I request our Civil HOD, Dr. Nagaraj sir, to join. Ashok Shukla sir, please join, sir. Thank you, everyone. I request Dr. Emily Shiny ma'am, HOD Department of CSE, to formally address the gathering.
Good morning. Good morning to one and all who are all present here and who are all connected in online from all over country. So I welcome you all for the two-day international conference on emerging trends and innovation in science, engineering and education. I wholeheartedly welcome all the dignitaries on the dais and off the dais. Actually, the aim of the conference is to provide a premier interdisciplinary platform for the researchers, research scholars, educators, PG students to present their most recent innovations, trends, challenges, etc. in these 2 days. Okay, so here now I welcome each and every one of you. Now remembering our honorable founder chairman, Dr. S.M. Megha-Tropiques, I heartily welcome our Honorable Chairperson, Mrs. Ramadevi Ma'am, in her absentia. I extend a great welcome to our energetic CEOs, Mr. Pramod Gowda sir and Mr. Rajiv Gowda sir in their absentia. Leadership is the capacity to translate vision into reality. I would like to extend a warm welcome to our Executive Director of EPGA, Dr. S.R. Shakapal sir, in his absentia. It is a well-known proverb that quality is never an accident. It is always the result of intelligent effort. With a genius like Dr. Raju Garudachar, the proverb seems to do justice. I welcome our chief guest for the conference, Dr. Raju Garudachar. I kindly request our principal to welcome him with a shawl and the bouquet. Thank you, sir. He is the man of distanced vision, an idol of knowledge. He shows the way, goes the way, and shows the way. He is the dynamic and energetic leader. He is the source of knowledge, and he is the visionary. He is our beloved senior vice president, Dr. Prakash sir. Now I request our conference coordinator, Dr. Chandrama Ravi ma'am, to come and welcome him with a bouquet. Thank you, sir. He is an idol of knowledge and experience, an inspiration to all of us. Now, I welcome our beloved principal of EPCT, Dr. T.K. Satish, for this inauguration. I request the conference coordinator, Professor Kesavan, to welcome him with the bouquet. Thank you, sir. I welcome our Vice Principal, Dr. Yogesh sir, and all the directors, HODs for this inauguration. I extend my warm welcome to all the keynote speakers who are connected from all over country. That is Mr. Anish Dhamasundar, founder and CEO, E5 Global Solutions from USA, and Mrs. Nivita Nixon, senior business consultant from Singapore, and Mr. Prakash, head of delivery services, Q Assure Technologies from Singapore, Dr. Girija, University of Applied Science and Technology, Muscat, and from ISRO, University of Tungo from Malaysia. I extend my warm welcome all the session chairs for all joining today's sessions. The overwhelming response received from all over country, from lot of authors. I appreciate all the authors of their exemplary contribution, and in particular the members of the program committee who reviewed the papers. I would like to congratulate the coordinators and all the organizers of this conference, and I welcome all the faculties, all the staffs, and all the students for this inauguration. Once again, a hearty welcome to one and all. I wish this conference a grand success. Thank you.
Thank you, ma'am. Education is the passport of future. For tomorrow belongs to those who prepare for it today. Education is the most powerful weapon we can use to change the world. We are blessed to have the presence of our Senior Vice President, Dr. S. Prakash sir. So I request sir to address the gathering.
Guru Brahma, Guru Vishnu, Guru Devo Maheshwara, Guru Sakshat Parat Brahma, Tasmai Shri Gurve. The blessings of all the gurus who nurtured me to be the good human being. Let me at the outset congratulate Computer Science Department first uh, for hosting this international conference. Respected chief guest of the conference today and the keynote speaker, Dr. Garudachar sir. It is indeed a great privilege and honor to host you, sir, and we want to listen to you now. Respected Dr. T.K. Satish, Principal, EPCET, HOD Computer Science, Professor Emily Madam, Directors, HODs, Faculty Fraternity, and my dear students. International Conference on Emerging Trends and Innovation in Science and Engineering. Innovation. As per 2021 data, India stands in Innovation Index at 46th place. In fact, 2015, we were 81 place. In this last few years, there is a exponential growth, people actually, in terms of patents filed, in terms of products generated from the innovation. That's a huge growth that has come. In fact, many people look towards US and the product that comes out, they rule us. I keep on telling to the people that there are 3 top product companies in IT sector: Google, Microsoft, and Meta. I'm not just using Facebook here. Facebook constitutes your Instagram, Facebook, a lot of other products. Google, if you see the series of products, all these 3 major companies take away huge revenue from us, from India, because today the largest revenue for all these top companies comes from India. The number of users are so high. So innovation is the key. It's very excellent to see the lot of tracks that has been there in this international conference. I was just looking over the brochure. It is called as Engineering and Technology and Science. That is ETSM track. There is ICT track, Information and Communication Technology track. Humanities, Social Science, Management and Education track. Ethical, Leadership and Influence. This is another track. Another track we have is Entrepreneurship. Another track is BPR, that is Bioscience and Pharmaceutical Research. Nicely, all the tracks is being covered. But I always tell that all international conferences where the deliberations happens on what are the trends that's happening, and the outcome should not just reflect in terms of only the papers. Many times, all these international conferences today, the common outcome is that how many papers I generate, how much is focus, how much is Web of Science, how much is the outcome. I think we should always look much beyond this. We always want to see that there is an impact to the community or to the social community. Very best innovation that came in 2021, people I should know, go the best innovation, go and Google it out. In 2021, very recently, the best innovation was AI-enabled earbuds for the people who are not able to hear. Every time is to basically we want to see that basically the lower noise, outside noise should be completely nullified, and you should amplify the listener and should get the great clarity. So can we enable AI? So this is the company called as Trace. Today it is the top innovative product of 2021. So we need to generate products which helps my country and my people. I always keep on telling to the students, the technology that work for other countries may not work for India. There are a lot of examples for this. The technology innovated by IBM, which works in US, may not work for India. There's a lot of case studies also. So we need to actually see that what is that required for Indian community, for Indian people, for Indian culture. So if I'm able to focus on all this and come out with a project and a product, then a paper should get generated. It should not be the reverse. Many times we always write the paper, get some outcome. Ultimately, I think this was one question was asked by my guide. I always telling him, who uses your PhD? Of course, you have citations and all these things, blah, blah, blah. But is there any impact onto is the social impact on it? So my humble request to all the research scholars who are all written papers and the student community is that kindly look beyond papers. We always tell that if you don't publish, you'll perish in teaching community. So it is not another P we should also add. We should also publish, we should also generate products. That is required for the Indian community. Now, just I have another 2-3 minutes time. Because many people don't want to give me the mic, because when I go on the mic, people start speaking up. The history of innovation that comes from India is too high. Unfortunately, we are now in the 46th index ranking. If I go back to history and see around 3000 BC, before Mughals invaded and before then British invaded, the innovation was something different. People used to look for us. We invented zero. Everyone knows if zero was not there, nothing would have happened. Binary system was invented by us. I think people, computer science students should know this. Fibonacci series was invented by us. And we were the first people to do the cataract surgery. I don't know what was the material science used by Muni called as Sushruta, who was the first person who actually removed the cataract from the eye. What was that needle material science? There was no invention of steel at that moment. And we were the first to predict light correctly. First plastic surgery was done by us. There is a huge history of innovation from India / Bharat. Unfortunately, we lost that glory because after that Mughals invaded. In fact, there is a record. Lot of medical innovations came from India. People know that there was a university called as Nalanda University. You should go and Google it. People from outside the country should come to this, eager to take up admission to this university. Very difficult to get the admissions. One of the Chinese monks has wrote that around 10,000 people were there in this university, and the richest medical innovations were scripted and recorded in the 6th floor of the Nalanda University. That's what he has mentioned. Now I want to tell you one story, how Nalanda University was destroyed. I want to tell you why I want to tell you that innovation is in our genes. Unfortunately, it was killed by our education system after independence. Nalanda University was completely destroyed by a Mughal king called as Bhaktiyar Khilji. Why he did it? I want to just tell to the students this one and I'll conclude. Because everyone should know the Indian heritage and Indian culture, what happened in 3000 BC, how we were rich in innovations. In fact, this king called as Bhaktiyar Khilji had some disease and he went out to a lot of people. Kaims, they call it as, they came and diagnosed him and not able to recover. So ultimately, one of the people told him that why can't you take the consultation from Nalanda University, and where there is some people, doctors who actually. So, but he made a condition. What was the condition is that you should not give me any pill that I should take because I don't want to take anything from Hindus. So then it was a challenge for the doctor fraternity there. Ultimately, one doctor, what he did is he gave some solution for him. He told that this page of Quran you read daily for 50 times. Okay. This page of Quran daily, morning and evening you should read. And ultimately, and he is without any pill, he started reading, and the disease went off, became normal. And then he told, oh, what is this happened by reading Quran? See, that's the strength of my Quran. In fact, after this person told he had kept some medicine, sprayed some medicine, and that page of the Quran where he used to smell, and it got cured, and he told at that moment. The negative part of the story is that in fact he saved his life. The unfortunate thing of the people is that he thought that these people are so smart. I came from Afghanistan and all these things to innovate you people. You people are, there's a rich culture here. I should destroy it. Unfortunate thing of this. So he lit the fire to the complete Nalanda universities. There is a record which has been put by a lot of people who told that this fire was continuously burning for 3 months. It's on record. Go to YouTube and see a lot of photos. Why I want to tell is that we carry a lot of innovation capabilities with us. Our DNA is with innovation. That's the reason today, if you take the top 3-4 MNC companies which rule the world, the CEOs are from India. Okay. Even I want to tell you, Sundar himself, once he launched one product, he mentioned this. You can go and watch in the YouTube. Yes, they have now Google has come out with a product where if you can put that device will go and check the iris and it will predict what are the diseases you have. In fact, he made a statement on the day when this launch was that he told that there was a lot of Rishu Munis in Bharat where by seeing their eyes, they used to predict not only what disease you have, they used to tell you that what you ate in the afternoon, what you ate in the evening. This is a level of technology, science, what we have nurtured ourselves and we have developed. So it is in our DNA. Innovation is in our DNA. Lot of trends have changed. My humble request to each and every research scholar, let us not end with only one P. That is paper at the end of the conference. Let us also come out with products. These products should actually make a huge difference to our social community. That has a social impact. So series of innovations has been done today. Of course, probably another down the line, what Narendra Modi tells that we should be the knowledge superpower. If we wish we have that capability to become the knowledge superpower, this generation should actually think more like this. So our education system now has changed. In fact, I always tell that There are a lot of talent which is there at the rural part of the India. We are not able to identify what is this talent, hidden talent in them. For them, because language is the barrier. English is the medium, is the barrier. Many times I thought that why can't we have a platform where I can code in Kannada? When Chinese can code, when Germans can code, when Russians can code, why can't we code? In fact, I want to tell you, when it comes to today the world is speaking about no code, less code. No, my complete Salesforce technologies, no code concept. That I don't need to code at all. I need to actually drag and drop and build the application instantly like a copy. It's called an instant application development. That's what your Salesforce does today. And a lot of technologies are also like this. No code, no code. In fact, the same thing came out when NASA started using Sanskrit language for their embedded system developments. Because low code is very less number of keywords. If I take one shloka, assume that there are around 80 to 100 keywords. Each keyword as embedded APIs. I can just call certain APIs like this. So that means we had our own strength. We lost this. So let us all re-innovate. There is a company called as GUI, which is incubated at IIT Madras. People should go there and see it out. This company has started today a platform to coding in regional language. First they started with Tamil. Now we can code in Kannada and code in Hindi also. And see the performance. Less number of code can be written in our local languages than in English. It's proved today. So let us think beyond what happens in the world. We should think of our people, what you require, and if we are able to give solutions to the common man, that's the contribution what we can do as a teaching faculty. Fine. Let me thank once again all the organizers. It's a great job here. I was very impressed with the track what you people have done. Happy to see some good deliberations happen from this conference. Thank you once again. All the best. God bless you.
Thank you, sir. It was very inspiring. Words motivate people to take action and make difference in life. We now have an opportunity to fuel our thoughts. I request our beloved principal, Dr. Sati sir, to speak few words and inspire our zeal.
Good morning. Respected Garudachar sir, Prakash sir, and Gimling madam, and all the coordinators of the conference. It has been a wonderful occasion for all of the people because of the various efforts that has been done by the Department of Computer Engineering. Today we are here. Okay, so lot of effort and lot of work has taken place probably for the last couple of months, 3 months as such. I think, coming on to the subject of the conference, particular, before I go into the particular this, we need to understand what is the purpose of a conference. Because I have been observing the conferences to take place in this particular podium itself for the last 1 year or 2 years, particular this. It happens to be just I put my paper and then I vanish away, particular this. What used to happen earlier, I will tell you, where essentially the conferences used to be far and in between, particular this. So the thing is that essentially gives you an opportunity to understand the various perspectives of different researchers as such. So that is how you will be able to think. In fact, even I can remember that whenever I have attended some of maybe cellular biology conferences or the conferences in the social particularities, they all give you some different ways of thinking together. And that is how essentially you will be able to improve your concept or your ability to think from a different viewpoint as such. If you do not understand the meaning of the perspective, then there is no need to understand about any person as such, okay, or any viewpoint as such. So that is how you will be able to develop a different personality altogether from attending a conference, and that is what essentially aids a person to develop together. And then coming on to the conference particular, this is a wonderful particular topic, and in fact, sir has been speaking about the innovation particular this. I think probably The most respected book on the innovation is Innovation Dilemma, that is written by Christensen, who essentially passed away 2 years ago. If you have got time, please read that out. That essentially is the Bible of the innovation research. Now, coming on to the particular this India way, if you look into that particular, probably for the last 5, 6 years, it has transformed in a big way. Probably the greatest the innovation that has been provided to the world platform, according to Bill Gates and by the other particular people, is the UPI particular. In fact, they have been requesting most of the other countries to make use of the UPI particular. The reason is that it is not just a gateway particular this. It takes away the lot of corruption particular this, lot of various particular things that is involved in that. And that, if you look into that, it essentially amounts to more than 2% of the GDP growth as such. So that's a huge particular this that if you look into. In India, if you look into that particular this, whether it is the various developments that have taken place in the logistics, whether it is in the e-commerce market, whether it is in any particular food delivery, any particular this that if you look into that, it's all because of the UPI particular. So one particular, in thought or one particular approach has led to more than 30 unicorns in India itself. And that is a huge particular research. So we need to look from the things from different perspective as such. What are the ways in which essentially we can make use of the particular purpose? And innovation or invention is not just to be thinking alone or different particular things. Even if you make use of a different already and the technology that is already there, and then give a different particular shape to that, that is also becomes an innovation. We have seen that particular this, for example, how essentially Dell became more popular compared to IBM particular this. It has been there particular this for a longer period of time. It's only the newer concept that they brought in terms of the logistics and the supply chain management. That is what essentially made Dell a bigger particular. So in any particular field, you don't have to compare innovation to Einstein as such, and then to be afraid of that particular. Any small work that you do that out, it essentially helps. Major more than any particular this, please keep attending the conferences, whether it may be on the online, whether it may be in the offline or in any particular, and that is where you learn many of the particular aspects of it. In fact, I mean, many of the conferences today I have been attending it out, or many of the talks. The thing is that today we have got an advantage also. You can do it offline also. So that's a bigger advantage as such. You don't have to be there at the same time. Because most of that will be recorded and will be available either on YouTube or any other particular, and then we can listen to that particular whenever you are traveling or any other particular. So there are various ways and avenues for the students, for the community particular people. Nothing wrong in anything you do that out. Only thing is you start writing, start expressing it out in your own words. That is what is very, very important. Because that is how you understand the originality that is involved in their particular. So these conferences or the various symposiums that we may conduct it out, it becomes an avenue for students to improve and to develop. In this particular sense, my sincere thanks and congratulations to the Madam and the Department of CSC for organizing this event and giving an opportunity for the various researchers and the various delegates who essentially have come from various parts of the world to be here and to contribute and make this a richer event as such. So once again, thank you all and all the best.
Thank you, sir. I'm profoundly delighted to take an opportunity to introduce the chief guest for the day, Dr. G. Raju Garudachar, sir, Project Director, Megha-Tropiques, ISRO Satellite Center, Bangalore. He has graduated in BE Electronics from Bangalore University, ME Electronics from BITS Pilani, and PhD in Electrical and Computer Engineering, University of Kansas, Lawrence, USA, with specialization in radar systems and remote sensing. His crowning achievements are, he joined in ISRO Ahmedabad as microwave engineer in 1972 and worked on microwave hardware and subsystems for spaceborne microwave remote sensing missions. He was a lead member in developing the first Indian remote sensing microwave payloads on Bhaskara 1 and 2 satellites. He was visiting scientist at DFVLR, West Germany from 1975 to 1982. He was a project manager and associate research engineer for the Antarctic Radar Project, USA. He has visited Antarctica twice under the Antarctic Radar Project, visited South Pole Antarctica in 1986, visited downstream B Glacier in the West Antarctica Mountains in 1987. Memberships of professional societies or bodies, IEEE senior member, founder member in Biological Engineering Society, Fellow of the Institute of Electronics and Telecommunication Engineers India, Life Member of the Indian Meteorological Society, Life Member of Astronautical Society of India, Co-Chair IEEE Geoscience and Remote Sensing Society Bangalore chapter. He was awarded with many national and international honors. Some of them are J. Das Gupta Gold Medal in 1981 for the best paper on meteorological instrumentation, certificate for setting foot on Amundsen Scott South Pole, awarded by US Antarctic Research Program, Antarctica Service Medal by US Navy in 1988 for service in Antarctica, US NSF Antarctica Service Medal for service in Antarctica, ISRO Team Excellence Award in 2011 for the Megha-Tropiques satellite project. Currently, he is working as professor in electronics and communication engineering in School of Engineering and Technology and International Institute of Aerospace Engineering and Management, Jain University. On behalf of management, I thank him for providing his gracious presence to join us today to enhance our knowledge. Thank you, sir. I now request our chief guest to grace the occasion by his words. Thank you, sir. Amuda. Put the chair and switch. Yeah, switch on for me.
Oh, no.
5 minutes, just it.
5 minutes.
Oh, no. Green light has come on.
Okay. What is this slide? I don't know. Put the first slide. Put the first slide. See whether the obstruct. Can you all see this slide?
Yes.
Switch off fully. Get off the button. Okay. Then this is not already. Then you not remove the. Anyway, you already decided. Okay. Good morning to all of you.
Good morning, sir.
It's a great pleasure and honor to be talking to a number of distinguished academicians, professors, CEOs across 6 to 7 countries. I'm sure many of you from other countries are also listening to or participating. It is a very, very nice organized, very, very well connected 6 tracks. I don't know all the tracks, of course. Mine is a limited knowledge. I should first accept the keynote by Dr. Prakash, who has used the master key, who has set the master keynote address and set the tone for this wonderful workshop. Before I proceed, I thank Professor Nagaraj, who triggered me to accept, and I very happily accepted to be with you. I thank Professor Satish, and of course, he's not there, our Prakash. He's not there, no? Where is he? He's there. Okay, so it's a wonderful lecture. It has already set the tone, particularly emphasizing the contribution by India and our predecessors. Therefore, my life has become an ordinary keynote speech. I hope I will do some justice and share with you my experiences in associating myself in only space research. I am basically from space department. Can you all hear me? Yeah. When I looked at the 6 tracks set by Madam, where is our Madam? It's very difficult to understand the entire thing. We have started from science, technology, mathematics. I don't know what you have omitted. Everything you have covered. Very difficult to cover everything to speak in a keynote kind of thing. But still, I chose a few of my whatever I can speak about, and I am going to present. You should bear with me because I'm only a teacher. You have heard the visionaries lecture, wonderful lecture, Dr. Prakash, and also Dr. Satish has also said the important point of not just listening to our writing papers. We heard very good advices. I'm sure all of you will follow that. And the most important suggestion made by our real visionary is that convert that into another P product. Okay, so there's a very wonderful way of looking at it. So, with that, I'm sure the conference has already set the tone for you to listen. Don't just listen to your own lecture and go away. Normally, the tendency is that whenever you make a presentation of your paper, you make your presentation and relax. But as very well can put, it's a question of networking with the people. Whether you have selected the proper subject, whether what you are doing is correct or not, or what others are doing, can I learn something? It's mutual. So, the important suggestion why I want to extend it, please listen to all these 2 days deliberations, and I'm sure you will be bringing some proceedings, and I wish that will be in the form of a compendium. I looked at various bullets in each of the 6 tracks. There are 80 specializations, not one or two, 80. Even if you spend 10 minutes for one track or one paper from one item, you don't need you need more than 2 days. I heard that there are more than 70 or 80 papers, and you have very little time. I don't want to take too much of your time, but I only want to share with you some of my experiences, particularly bringing out what's happening in the world. So I will start with my presentation because that is my normal way of uh, exchanging, so that I cannot speak without some basic pictures and diagrams. So I have my please go back to the first one, first slide. So I just tried to twist the title itself of this conference, Emerging Trends and Issues in Climate Change. I want to emphasize a few only because these are important things, apart not that others are not important. This is what my knowledge is a little bit close to this. I want to address more from the track one. Climate change, remote sensing, and astronomy. This is science. Some answers from space missions. I hope you will bear with me if I dwell upon this topic. You want to close the door? Are you able to see this presentation PPT? Okay. All right. Thank you. So I will take about how much time do I have, madam?
Yes. Yes.
30 minutes. My time limit.
Yeah.
If otherwise I'll keep on talking. There's a problem. So let me try to give me 5 minutes warning to stop. So that way I will conclude. So it's always a pleasure to talk to students. Always a pleasure to be with academicians because you become more young. Wali had, you know the story in Ramayana. Rama was trying to kill Wali. Wali had a special power. That whoever is in front of him will get that strength, more than that strength. So that was a story which, because of this, it could not directly kill him. So I'm trying to use that. Whenever I am meeting younger people, I become younger. As young as you are, or the average, or whatever. So that's always my pleasure. Thank you for this opportunity. And let me try to present a few things in this topic I have selected. Next slide, please. So, content of this lecture, a brief overview of the emerging trends in a few fields of innovation, commensurate with scope of the conference. The lecture will briefly address both challenges and risks involved. Whenever you go for innovation, there will be some risks. And some of the current trends and directions for a few solutions, but more of questions. This conference may not answer all the uh, questions, but they may create more questions. That's the way we have to have. Networking is an important opportunity. And so in this particular lecture, I will share about half an hour's matter, whatever I have addressed in the field of climate change and remote sensing and a few of the astronomy. Because in the track 4, you have got something with respect to science, physics, chemistry, mathematics, everything is there in that. And so I thought I took the liberty to add a few flavor to this in the form of something connected with astronomy. All of you should know probably what is the latest in astronomy today. All of you would have heard of, all of you would have been watching the James Webb Telescope, JWST, James Webb Space Telescope, doing wonderful things. That is the latest. It is almost going towards almost 15 million kilometers. The telescope is the most powerful. What is the purpose? To find answers for the origin of life. That is a very, very challenging. Today's not just science, very, very serious and complex technological innovations have been made through this. So I thought I should add a few slides about that. And let me go to the next one. So that's how my please, next. Okay, all of you know climate change. Everybody talks about climate change. Almost everyone is suffering from the climate change. What is the most important and difficult thing all of you might have not really felt is that sea level is rising. Why? Global warming. Why? Because we are industrialized. So there's a fear. There's a fear that if the temperature today rises by another 1.5 degrees, the trend you cannot control. It is irreversible of snow melting. If all the ice, what is made all the ice, North Pole, South Pole, and the mountain ice melts, there will be no Bombay. There will be no more coastal cities. They'll all be drenched. There's a fear. The latest fear is that we were thinking 2100 it might happen. All of us can relax. No, it's not. It's coming clear. No. Closer and closer. Latest trend was 2000 in another 2070. 2070 is coming closer to even 2050. I don't want to scare you or bring the value. This thing, it's important. There's a big group of people, what is known as IPCC. That's a big, about several, I think more than 100 countries are worried about this. They want to control global warming. That's why the innovation with respect to electric vehicles, green energy, all that thing is happening. Why? Because of the fear. The fear that it is coming faster and faster. When I was working on my project in 1982, there was a big news. The temperature of the earth has gone, our sea has gone up by 0.1 degree centigrade in 100 years. Who cares? 0.1 degree rise in 100 years, nobody might bother in these years. But it's coming very, very fast. Because there's a very big danger. Antarctic and Arctic ice is melting. People are from a lower range have been asked to go to higher levels. I heard some news about a complete village in the Himalayas was vacated, or they ran away from that because they were depending on a glacier water. Water was not available, and they vacated the place. So it's coming closer to our current day life. What do? We have to work on how to uh, delay the global warming or reduce pollution. What is the cause of global warming? We use a lot of vehicles, and they are creating carbon footprint is higher, and all those things you know very well. It's causing because of melting of the ice in the Himalayas and the glaciers and the uh, polar regions. Now, changing climate is several. Now it's a question of survival issue. And I will, that's one part of the story which I'll be discussing with a few slides showing the dangerous way things are happening. And I will also talk about few other things: communication, navigation, and remote sensing. And finally, a few slides about the astronomy. Please go to the next one. We have a very wide range of tracks. I only have shown the first two: ETSM, engineering, technology, science, and M is mathematics. So then for communication, two things I'm going to address. Please go to the next one. Next slide, please. Okay. What I would like to bring out is climate change and environmental issues. Please. Next slide. Okay. Causes and effects. Emission of pollutants, development, infrastructure building, greenhouse effects, global warming, and I has already told you. And that we don't know anything about many of these. We need innovation because no proper models are available, inadequate knowledge on the above, all these sea level rise. Because whatever we have today, they are not enough to make a proper model, and the large resources required, not only human, but the computer resources. So there's a lot of scope for innovation to reduce, to make a better model, and how to control the warming of the atmosphere and the whole earth picture. Next one, please. Just to show a few alarming picture of how the sea level rise. It's only a partial data, but there's a big trend going up and up. It's only some data from the satellite images. This shows that after some 2 decades or 3 decades, what is if you don't control, it may happen in 2 decades. But if you control, you may survive up to 2100. But that is changing because there is no proper control. There are political reasons that why should I reduce my carbon footprint? Why not others do? This is a different kind of argument. So this shows the increasing temperature or the rise in the sea level measured by space-borne altimeter. Altimeter is nothing but it measures the height. So height of the level of sea is measured through a space-borne system. So this is the trend. If it goes like that, it will finally increase the temperature to such an extent that sea level will rise by 70 meters. Please note, hypothetically, if you don't control the warming and the ice melts both in the Antarctic and Arctic and the mountains, 70 meters is not a small height. So many other coastal zones will be washed out, will completely drown. Next one. So what is the thing that people are doing? Where I was partly connected, how to estimate whether the sea level with the ice thickness is increasing or decreasing. So one experiment was done. This is by chance, that is, it was not really meant for the an aeroplane mass. Just give a historical background of this is a more technical information. Somebody was flying over the Greenland, and they were about to land, and the aeroplane crashed. Aeroplane crashed because of what? because there was an altimeter. The altimeter measured the bottom. The pulse came from the bottom, as I said here. There is a return from the radar returns were there. Radars are used for radars altimeters are measured for measuring the are used for measuring height. So the return from the top layer of the Antarctic ice was very small. The return from the bottom, that is where the ice thickness at the bottom is nothing but the top. That was strong. The pilot saw that strong return. He ignored the small return. So he landed prematurely and the whole aircraft was, damaged, but unfortunately no loss of life because the Greenland ice, the soft landing took place. So what does it, what did give us? So there was a method to find out the thickness of ice. There are big glaciers, there are very big glaciers, moving very slowly and finally collapsing in the bottom. And there are large scale research going on to see whether mass of ice is increasing or decreasing. We don't know. So there are a lot of different universities, different countries, including India. We have been conducting a lot of surveys, measurements by visiting the South Pole and North Pole, as well as the Himalayan mountains, to study the effects of global warming and what's happening to the glaciers. So this particular experience gave us an interesting information that I can use a radar for detecting thickness of ice. So that's how we started the survey about the ice. Next one. Okay, so this is about what I just now said, that you can find out thickness. I don't want to go and read every word. I will leave the material with madam. You can always take it and for more serious studies. So this is how we found out a method of measuring thickness of ice. The thickness of ice in the South Pole or average in the Arctic, Antarctic is about 3 kilometers. What you have seen in the sightseeing places like Kashmir or any other place only 2 meters. Imagine mass of ice which is about 5 kilometers thick, and the impact of a piece of it going and melting and collapse into the sea. That's why the sea level rise. Next one. So at one point, where I had a personal experience of conducting this measurement was to see the thickness of ice. Here, this is the bottom of the interface of the thickness, the interface of the ice and rock. So about 1.2 to 1.2 kilometers of thickness. It just it says experiment conducted during for a PhD work, but they give valuable information for finding out whether there is increase in snowfall or decrease in the snow in the ice accumulation. Next one. So this is about a general how cryosphere. I got enough time. Another 10 minutes.
Yeah, another 10 minutes.
I'll quickly go through some of the other topics because all of you must be waiting for listening to the people who have really done something. And I'm also don't want to take up like I don't want to talk like I talk in the classroom, but I bring it very few points and then stop in about 10 minutes. So I wanted to add a few things about remote sensing. Next one, please. All of you know that remote sensing. I think most of you have heard of remote sensing technique. We don't have to. Mostly application is in weather forecasting and also monitoring the resources on Earth. So a few slides on that. Next one. So some states, I don't want to go to them. At least there are many. I want to bring out only one thing. If you want to make why our weather forecasting is very poor, because it's very, very dynamic. We don't know what's happening in the next hour, but models are not very good. So to measure one particular parameter like rainfall, 8 satellites were used in a global precipitation mission, which was a very widely used. Even today it's working, but still not reliable data is coming. So for what I'm telling you, why I'm telling you all these things is because to measure a climate related parameter is not easy. because it's varying very fast and parameters are very, very, very many are there. Next one. So just want to say a few things about what is the latest sensor available to us. The latest sensor available to us is called synthetic aperture radar. The radar is nothing but you send a pulse, it comes back with a delay, and the shape of the pulse tells the story about what you're looking at. It can be used for vegetation, used for soil, water, anything. So it's a very powerful sensor. Synthetic aperture radar will be the one. Next one, I will talk a few things. What is the meaning of a normal radar? Normal radar is not like you have an antenna. I hope all of you are comfortable with my presentation because I don't want to again bring a lot of technology part, but still like flavor of that. Okay, you have telescope, bigger the telescope, smaller is the better is the resolution. Isn't it? You want to see a small thing in your camera or a telescope, you will need a huge mirror or huge optics. So I cannot put a very huge optics in my satellite if I want to see the requirement of a military person wanting to see if it is moving. Today we have such powerful radars where people can see a small bird moving from space. Lot of processing is required. That's why a lot of requirement from image processing is to be focused. We are learning a lot. We are learning through more and more sensors. Today we have in India the Garudachar 3, which will see 1 meter, a fraction of a meter data from 600 kilometers. Same way, radars can do similar performance of a fraction of a meter by various processing techniques, what is known as synthesis of the signal. Don't want to go to the details, but try to remember two things. Optical radars, optical cameras don't work in the night, whereas microwave radars will be able to work irrespective of the day, night, smoke, or fog. So this particular improvement in the synthetic aperture radar, just only as I said, just remember that you are looking at the same point several times. Suppose you are going in the train, moving train, want to read the name of the railway station, you cannot see because train is moving very fast. So what will you do? Look at the same point for a long time. You are synthesizing the signals and then trying to read whether you are in the right, whether you are in the Bengaluru or cantonment. That's how to make you understand the technology of a synthetic aperture radar. I wanted to compare this particular example, and that's all. There is nothing very big, but this is easy. It can be done. But when you do the electronic processing, it's a lot of challenge. It's not fully operationalized, and we are having at least several radars in the military applications, but they are not available to public domain. We have in Indian ISRO has developed radars for general security applications where you can see small details like the movement of a vehicle. Okay? So this is another one small deviation. There are very many things which are not understood. We cannot predict. We have not been able to do. We are not able to predict earthquakes. We are not able to predict tsunamis. All of you know what is the tsunami of our 2007 or sometime. So tens of thousands of people were killed. So we claim we have many satellites, we cannot predict tsunami. So we have to work a lot, and there are some efforts done taking about hundreds of satellites together to monitor an ocean because we don't know where from the tsunami wave comes. So this is one example. An example that we done after the tsunami has occurred. It's about not from earthquake. Similar is about earthquake. As I said, small movements are possible by synthetic aperture radar, and the problem is you cannot detect, you cannot predict an earthquake. Two things are still pending. You cannot predict an earthquake, you cannot predict a tsunami. So similar, that's what the synthetic aperture radars are being used now. And you in future, I hope some of you will take up topics in remote sensing and then do some useful, innovative things. Okay, next one, please, madam. Okay, this is what the new. What I'm coming to the same topic of synthetic aperture radar. All of you know we have an orbiter. Orbiter is nothing but a small satellite going around the moon. The Chandrayaan-2 failed in the lander, but orbiter is still there. You can take data from that orbiter, from the radar. What is important of that radar is it will tell you something about the locked up ice inside the below the surface of the moon. So academic institutions are given free hand to access these data and do analysis about the content of the quantity of water available on moon. Why are we worried about quantity of water when we don't know what is happening on the earth? There are some innovative things people are interested. Tomorrow, or maybe after some time, China is, for example, I'm giving one example. They want to have a station in on the moon, use the water available. You don't have to transport from the ground, from the earth, spending a lot of money. Water is available on the moon. Whether how much is available is the one. I hope some of you will work on such problem. Data is available. That is nothing but two radars working on the orbiter can detect and you can quantify using the data the amount of ice or water available. Next one. Okay. One more thing is very huge. Please next page. Let us. There are two more synthetic aperture radars on ISRO's program to be launched in 2023. It's called NASA ISRO SAR synthetic aperture radar used for agriculture, forestry, and many more applications. Next one. That's about the remote sensing part. Very briefly, we covered slightly on the climate and the 5 minutes. I think I don't see more than another 5 minutes. Can you give me the 5 10 minutes, madam? Okay. So class of I don't want to go to details. Let's quickly go because of shortage of time. Many different types of radars. I don't want to list and read everything. There are many types of radar for scientific experiments. You cross the atmosphere of one of the maybe Mars when you are going towards Jupiter, and that's called flyby. Orbital spacecraft, what we know already, going around a particular uh, planet. So communication satellites and navigation satellites are very common to all of you. As I said, there are different types. Well, let me focus mostly. Okay, that is warning for me to stop. So I think it's fine. So what I want to bring out one particular thing is that all of you are using GPS. GPS is the global positioning system. But still ISRO is has developed our own GPS. Can anybody say what is that? IRNSS, Indian Regional Navigation Satellite System. When we are getting very good data from GPS, 5 meters accuracy, we are developing 20-meter accuracy. What is use you ask? We suffered because of non-availability of GPS during our war time. We have to be careful. GPS is a very important device for finding out your position, especially for military applications. All of us are using daily for tracking your taxi or your own movements. So common is in your pocket. What is it doing? How it is doing? It is the question. That's what you have to learn in navigation in our ISRO's Indian Regional Navigation Satellite System. We don't have our own chip. Please note, people who are youngsters here, you are given this task, you should take up the task of developing a chip which you can put in your mobile. We don't have. We are trying, but we don't have. But we have to develop a small chip. All your mobiles have chips from Taiwan and Korea, such things, isn't it? Am I correct? So they can do any mischief. They can misguide you if they change the software. So please be aware of the importance of innovation. Nothing but miniaturize the IRS receiver into a small piece of chip. Okay. Another important thing is about we are all talking about Gaganyaan. We already tried in ISRO. India has got to go to the moon, outer space. They made a simple uh, attempt to send a satellite to bring it back. Satellite recovery experiment to be done. Now this is one of the biggest technologies today on which people were even a common man. One need not be an expert in aeronautics or one need not be a pilot to go to space. In some of the experiments in recent next one, please. Okay, here I'm just to quote it. An ordinary student, a student of 18 years and a person of 82 years went to the space and came back. Please note that no age bar. You and I both are eligible to go there. So that is the technology development, that safety, and you can it's almost become a space tourism. That's the technology we have done. Next one. But there are a lot of problems. All of you know about the Starlinks, isn't it? What is Starlinks? Everybody wants to have very fast internet connection, very large amount of data to be downloaded. And whenever you go in the cities and GPS not available, your phone is not connecting, all these problems are. Therefore, to solve that, there is a proposal to have thousands, tens of thousands of satellites in space. That's called Starlinks, and this is yet to happen. It's happening in the process. Next one. But what is danger? Danger is already we have junk. What is the junk? Space is crowded with many pieces of rockets and non-functional satellites. Imagine today we have 30,000 satellites. We are going to launch 30,000 in the next few months, or depending upon some of the policies. Imagine that kind of thing will come in. You cannot move around at all. My experience, I'll tell you one quick experience. This thing is, we are about to launch a satellite at 11 o'clock, 11 a.m. They asked us to wait. Why? Because some dabba is coming and hitting your satellite. Or something, some junk. So we cannot control. This problem is very much there. So that's a thing which has been faced by the people living in the space station. They had to steer the International Space Station to escape from the hit. And there is a small damage done by that with a small micro particle. Please go to the next one. Next one. One important thing I'll tell you, how much money is being spent for various applications. Japanese spent 100 crores, 1,000 crores, not 100, 1,000 crores to bring 2 grams of material from an asteroid. All of you, no problem. Please watch all those things. To bring 2 grams from an asteroid, what is an asteroid? Nothing but free moving meteorite kind of particle that's rich with minerals. So they spent 1640 crore yen. That is about, this is about, I converted, that is about 1,000 crores rupees for one mission to bring 5.4 grams of sample. They have already done, they are going ahead with this. Next one. That's the kind of technology going on. China wants to build a station on the moon itself. They want to use the moon material and develop systems for launching to extragalactic spaces. That's the kind of technology going on. Few things about space communication. As I was telling, next one, please go ahead. Go ahead. So it is nothing but you want to have everything fast, everything more, and so number of satellites are being developed. That is the kind of demand from the users. Information content, speed, and spatial. Therefore, there is a big importance. There is a big demand for launching more and more satellites. Next one. So India has launched so many of the satellites. I don't want to go through that. Please look at all kinds. So the best satellite so far launched, or the biggest satellite, is for connecting the Gram Panchayat using this satellite, T-Sat 7. That's one example I wanted to trigger. The application is going to the ordinary village. Dr. Prakash was telling about the demand. When you are developing something, whether it's going to the right person, that's the kind of thing that is addressed here under the Digital India program. Gram Panchayat by the satellite. Next one. But there are problems. Now we are going for 5G. I thought I'll bring some of the issues. 5G, what is the problem? Anybody knows? Anybody tell about the 5G? The people are worried about. There's a protest not to use 5G. The reason is there's interfering with some part of the people, some other particular US, is interfering with the aircraft navigation. Therefore, there is still a question mark whether 5G is allowed in some countries, but we have to find ways. So issues, there are no answers yet. Next one, last one, navigation, and one more. Please go ahead. I already talked about there are so many number of satellites, so many missions. Each country, once upon a time, we had only GPS of America, but every country, almost all the countries I have mentioned here, 6 missions are going around, and all of them are yet to operate, but they are in the process. Next one, ours is IRN, India's remote sensing navigation mission. Next one, this is how it is connected. We have 7 satellites. All of you should attempt, I should say, that this cannot be detected, this cannot be received in your mobile unless you make a chip. But this is working with this is the scheme in very soon. We have some, ISRO India has some collaboration, again, there's a collaboration not developed in India. We cannot develop an IC, proper IC, which will work, or a chip for our putting it on the mobile. There's a big question mark. We are still not safe. Next one. So the last application is nowadays there is what is GNSS farming. Information comes through the some of these drones, which will tell you something about helping you locations and movements guided by GNSS. When you have small craft, it's okay, but in the large, bigger areas, you need there's some kind of support coming right from the applications defense to the farmer. This is what I would like to bring up. Last few slides, science and astronomy. Next one. Chandrayaan, I have already told you. Chandrayaan 2, next one, is also another Chandrayaan 2 is orbiter. Now, all of you have also seen the Mars orbiter mission, and the next mission is towards hopefully mission to Venus. People who are creative and want to get motivated should think of preparing some kind of rover. That's what you can probably feel there will be feasibility. If you write proposals, especially computer and electronics people, you should be able to develop a rover for whatever applications which is lacking. Some of the rovers are failed. Okay. Then this one, another interesting thing is we don't know anything about many things are known and not known about the sun. So a probe has been sent towards the sun, going almost several million or even billions of kilometers closer to sun. India also, next one, the probe. India also is looking at mission to study the sun and the radiation properties. It's the future, near future. 2 of them I just put. There are many more. Next one. So you all have known that we have been able to launch a satellite. Means the other space agencies have been able to send helicopters on the moon to survey the Mars. Next one. This is the way it looks. One of the Martian surface. And the last topic is about what I just now told. Is about the JWST. Before JWST, we had James Webb Telescope, which is going to give us very wonderful picture. We had this four. All of you have probably heard of Hubble telescope. Hubble is one of the next slide says that what was seen in the early days has improved into higher and higher resolution. Next one, please. This is a comparison how better it is improved with different kinds of missions. Next one. So, this is the kind of thing which is giving you lot of information. Maybe I'm not able to personally interpret because I'm not an astronomer, but people who are working in this field have found lot of details as shown in the next one. Next one, please. This is one of the most important development. This is my last subtopic. James Webb Telescope. James Webb Space Telescope is orbiting at around 15 million kilometers away it's today at the 15 million kilometers. It's looking at beyond the galaxy. Last slide, next slide, please. This is how it has been covered for. It's a cover for protecting it from the thermal radiation. Very impressive, very complex. There are a big question mark whether it will be successful or not. It was very great success, and we got one initial results. Next one. This is how it looks. Can you see from naked eye? No. This is known. It is somehow called cartwheel. It looks like a wheel. This is a galaxy detected about a month back. Today we may not be able to understand what is going on, to understand whether there is life beyond the earth, or how long ago earth was, the life began on earth. A lot of questions, unanswered questions are possible through this experiment. Next one. So to conclude, space offers many challenges, allows participation by scientists and senior academicians, but also inspires students, starting from discovery related to last slide I showed, extragalactic observation beyond Earth, to farming on the Earth. Please note that we are not really focusing. We are using the space even to look at the resources, help the ultimate requirement of the farmer to find out the vegetation, monitoring the vegetation, etc. And that is what I want you to remember, the capabilities of the challenges as well as the applications of the space. Thank you. Next one, and last one.
Thank you, sir, for fueling our thoughts. Now I request our Chief Guest, Dr. Raju Garudachar, sir, to release the IESEE 2022 proceedings.
Four times is complete completion. I don't know very difficult to find.
I request Dr. I request Prasanna Kamalavalli ma'am to speak a few words about the conference. A very good morning and warm welcome to one and all gathered here. I would like to extend a warm welcome to all the presenters and participants for this International Conference on Emerging Trends and Innovation in Science, Engineering and Education. It is IESE 2022. I would like to express our sincere gratitude to our invited speakers. The Department of Computer Science and Engineering organized this international conference as the first step toward a world-class conference on computer science and transdisciplinary subjects. We are sure that this international conference will provide opportunity for exchanging unique research ideas and viewpoints, being motivated to conduct further research. We have received 75 papers from different places like Karnataka, Maharashtra, Andhra Pradesh, and Tamil Nadu, out of which 25 papers were selected by the technical committee. The extended papers will be published in Scopus Journal. We would like to express our appreciation to the members of the Technical Advisory Committee for their careful review of the selected papers and to the organizing committee for their time and effort in editing the proceedings. We would like to convey our gratitude to the authors who submitted excellent papers for this conference. Thank you, one and all. Thank you, ma'am. I request our Principal Dr. Satish sir to honor our Chief Guest Dr. Raju sir with a memento. Let us end this event with a vote of thanks, appreciation, and gratitude to all those who made this event a grand success. I request Professor Keshwan sir to propose the vote of thanks.
Good morning to all present here. Myself Keshavan. On behalf of ISRO College of Engineering and Technology, I would like to express my gratitude to all esteemed dignitaries of today's conference for their presence to make them great success. I would like to extend my gratitude to our honored chief guest of today's function, Dr. Raju sir, former project director, ISRO Bangalore, for attending this function in his busy schedule to grace this event. It was a really wonderful speech, sir, about climate change, remote sensing, and space astronomy, radar signals, and aircraft altimeters. It was a really wonderful speech, sir. Thank you, sir. I express my gratitude to our Senior Vice President, Dr. Prakash sir, for joining with us. And it was a wonderful speech about the innovations, and it was really inspiring for us. Thank you, sir. I extend my sincere thanks to our respected principal, Dr. Satish sir, for joining with us. Thank you, sir. And also extend my sincere thanks to our beloved HOD madam, Dr. Emelina, for supporting us. Thank you. And also extend my gratitude to Dr. Sengamali Velli ma'am, coordinator of this today's conference, for organizing such a wonderful event. Thank you, ma'am. Last but not least, I thank all the HODs of various departments, faculties, non-teaching faculties, and my dear students for joining with us and for making this grand success. Thank you, one and all, once again.
I request everyone to stand for the national anthem.
नमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तब शुभ आशीष मांगे गाओगे तब जय गाथा जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
I request all to have high tea which is arranged outside the seminar hall. All the students, everyone.